I'm Alabbas. I'm from Microsoft. I am a program manager on the Internet Explorer team, and I mainly work on those technologies right there, so web storage, IndexedDB, file API, and web storage. I just want to see the range of people here. Who is really knowledgeable about these topics? If you could just raise your hands. No one? Okay. And who's never heard about these before? Okay. So there's a few people. Okay. And then some people, I guess the rest of you are familiar with it, but are here to learn more about it, that kind of stuff. Okay, that's cool. So we do a lot on the internet today. I think so, yeah. Would you like me to use the mic? Yeah? Okay. Okay, so we do a lot on the internet today. I think also the video feed takes it from this, right? Probably. Okay, so we read news articles, we watch videos, we get maybe a recipe for dinner, read and write emails, all those things. And it's a pretty great place to do all of this stuff. But we have a bit of a problem, and I'm sure you guys know what these problems are. Obviously, sometimes the bars drop and we're left with nothing, no internet connection, or the internet is actually really slow and you're not able to actually get anything done on the internet. Actually, I was just staying at a hotel here and the internet was pretty much useless. I couldn't get anything done and I pretty much had to do nothing, wait, just kill time, and it was pretty crappy. But you know, these are the kinds of things we have to deal with. You could also deal with issues like a spotty internet connection. So maybe it's wavering and it's flaky and you're not really getting exactly the amount of stream you want to get. So in essence, people generally want apps and actually websites to just work. They don't want them to kind of just halt and not do anything just because you don't have an internet connection. So as web developers, there's something we can do to kind of mitigate this issue. And it's quite simple. We just have to think of building our apps and our websites to work offline first. So I'm sure you guys maybe have heard about this paradigm before, and basically it works like this. First, what you want to do is you want to build your application or your site so that it works without any internet or any network connectivity, and kind of give the minimal experience that you can possibly give the user. Or if it's just something like a white page and it just says you need an internet connection, at least that's better than getting nothing at all and some people are just waiting for that screen to load up, because that's not a great experience and people don't like that. I think there's actually a lot of apps out there currently where you have to open it up and have an internet connection that's running just so that you can use the application. For example, games, if they require a server connection so that you can make sure that all of the money or whatever else the currency is in that game would actually be able to work. And after you've built it that way, you can augment your application so that it could take advantage of connectivity and so that it could enrich the user experience with the internet. So there's a few things we can do that we should consider when we try to give this offline support. So one thing is we can cache static resources. Now this is something where anything like images, HTML, CSS, JavaScript, we can actually cache that stuff so that it's available even when it's offline, and we can have the main application load up. There's also things like caching the local data, so anything like JSON or strings or unstructured data files, we can cache those as well and have them available offline. And we can also, and partly with that, what you'd want to do is separate out the data and the UI, so something like an MVC kind of paradigm, just so that you're able to plug in the data from the local cache stores right into the UI. And something else you'd want to consider is syncing up that data back to the application, either from the server or back to the server, so that you're getting that consistent experience, especially if you have multiple instances of the application on multiple devices, or if you have it in different tabs or different windows. You just want to make sure that if you're doing something in those different areas, that it's still going to be the same data on those different instances of the application. Something else you might want to consider is something like, what if you have multiple instances of the application open, and in one of the instances you're offline and you do a bunch of stuff, you make a bunch of edits, and then all of a sudden you get connectivity, and now you got to push that up all to the cloud, and you want to make sure all of that gets merged up and all of the conflicts resolved. So just some things to think about. You also got to think about sporadic connectivity. So if you're not having a consistent connection to the internet, you want to make sure that you're able to compensate for that and get whatever you need from the caches as opposed to from the internet. And something else you might want to think about is if the app is being closed, or if the site, you're leaving the site, that kind of thing, you might want to save anything that you have that you want to keep offline in case that person revisits the site or the application when they don't have an internet connection. So there's actually quite a breadth of applications we can think about when we're talking about offline scenarios and supporting these offline scenarios. There's ones that have very client-heavy kind of data, and they do a lot of processing on the client, so within the device or within the browser. There's also the ones that require the server quite a bit, something that needs a connection and would like to do a lot of the stuff on the server, sending emails and all that other stuff. So here are a few applications that we could think about in terms of these the spectra of different applications. So we have something maybe like a kid's book, where you want to have all of your resources cached, so that if there's any images or sounds, anything like that, you want to make sure that that's all there, and so that you can access it after. You want to also, if you have like a game that has scores, you want to make sure that if there's any of those scores that you want to save and have them sent up to the server afterwards via XHR, you want to make sure that you're saving those as well, for being able to actually use it while you're not connected, but able to post that up so that it will show up on leaderboards afterwards. Something like an image viewer, maybe you wouldn't want to upload it to a server and then have it process it, to make a thumbnail and then bring it back to you, just so that you get this smaller image for a file viewer kind of thing. Maybe you want to do that right on the browser, and that's something that we want to try to do, just because people are not always going to be connected to the internet. Something like a recipe book, if you're out there going shopping for ingredients and you want to check your recipes and see exactly what you're trying to buy, it might be useful to have something that lets you see exactly what you can get. Something like that would require caching data exactly like the kids book. Also having the resources like the database, all the ingredients, all the recipes, you want to make sure that's all cached as well. And then of course you have email clients, which are pretty heavy on the server end, which are also can do a lot of client-side processing. For example, if you're saving drafts, if you're writing a lot of emails and you want to make sure that those are there, you got to also cache those as well. So in terms of the technologies that we have to think about to enable these scenarios, these are pretty much them. You have application cache for the kids book. You have offline and online events to kind of figure out what your connectivity status is for games with the scores, so that you know when to post those scores up, and you can use web storage to do that. For the image viewer, something like file APIs, which will allow you to process those files right on the client. You also can do an XHR send to actually upload that data to the server. For the recipe book, you want to make sure you download all the data from the server right onto your client, and then have that available right into your local database, something that's fully capable and is able to search through stuff. For the email client, it's very similar. You want to also have the ability to upload, so that if you're going to send an email, you can upload that to the server, and then it could dispatch that. So we're going to start with online and offline events. So what this pretty much gives us is the ability to detect when we have a connection or when we don't. So basically the paradigm is we cache everything locally, and then once we do have a connection, when we find out that we do, we can upload that to the server so that it's all synced up. You might want to consider, though, that sending to the server can still fail. There might still be a choppy connection when you do send it to the server. And, of course, you can't actually rely on this event all the time. Maybe you connect it to the Wi-Fi at your hotel or at the airport, and then you have to actually go into your browser and accept the terms and conditions and actually get connected to the internet. Whereas this event, which I'll show you now, will probably report as being online, even though you're probably not, because you can't actually connect. So something maybe like pinging to the server to check if you're actually online would be something useful to do. So here's something pretty simple, some pretty simple code, just to see how we would actually check if we're online. So this is how we do it, navigator.online. Now I know that there's like the capital L, and that's intentional. You have to do it that way. This is something that was decided on, and it's stuck since. So that's pretty much how you do it, and that will be a Boolean, true or false. And then after, if you like, you can also do event listeners on the window object by doing add event listener and adding the event for the online or the offline events, and then you can handle that change by actually going to a method that will look through it and check the type. Or you could do it in a different way where you just check navigator.online within the method. Either way will work. So the other thing we could do is we can use the application cache. It's pretty magical. I think a lot of people have heard about this, and there's a lot of stuff that's going around about whether or not we should actually be using it. We do get a lot of advantages from it. So first off, we get to cache resources pretty easily. And we get to explicitly cache them, or we can have like a fallback mechanism where we can provide a pattern URL which will actually fall back to another page that we'd want to cache. Also, we can specify the objects or the resources that would require network connectivity. And actually, with the other advantage we get from this is that if your site goes down because of maintenance or some hiccup that you have, the user will still get an offline experience because they'll be able to access your site. So that's kind of an advantage for sites. We also get some performance improvements because the requests are actually being made to the application cache versus making HTTP requests, which is quite expensive. So it's being read right off of the disk. We can also prefetch resources, so we can specify resources that we may not use at the initial load of the site or the application, but we're able to use those later on, and they'll be available for our use. So just to kind of give you guys an idea of how this looks, it's sort of like this. You have your manifest file. Note that the MIME type has to be text/cache-manifest. So if you're using Apache, you'd have to add that type, for example. And basically, you'd have your HTML file, and then you'd have this manifest file for your app cache, which would specify exactly what you're caching. So under the cache header, you would specify, for example, logo.png, and that will explicitly cache logo.png. We can also specifically say that things should require an internet connection. For example, vid.mp4. I don't know if you'd want to cache that or not, but if you did, you would have that in the cache header, but if you didn't, then you would have it under network. And then there's also a fallback mechanism. So if you don't have internet connectivity and if your resource matches a URL that's under here, so for example, img.png, you can have that fallback to no img.png, and that's a nice way of being able to degrade the experience gracefully so that people are still able to see what they want to see, perhaps not in the best light though. So there's a few important things to note here. The HTML file that actually has the manifest at the top there also gets cached, so you don't have to explicitly cache that as well. So I'm just going to do a demo now for AppCache. I wonder if this is... Okay. So this is probably something you might want to do. Have a bunch of resources such as videos and images and other content like MP3s. I don't know if the sound will work here, but pretty much a bunch of resources that you want to cache so that it's available offline. And what we can do here is we can press start, and this is just a little game for kids where they can click on each one of these. It actually has sound, but it's probably pretty annoying, so it's probably fine that it's not, that you guys can't hear it. So yeah, you click on them and it tells you, squirrel. That's great. And you can click here and it's gonna say cat, hopefully, yeah. Okay, so that's pretty much how this works, and it's using JavaScript and HTML and CSS, and this is all cached, so this could be accessed offline. So for example, if you take this with you on a tablet and you're going into the car, and who knows, maybe you have like 20 kids, and you want to give them all this application, you just preload it right on your device right before you go into the car, and then you give it to them. And you're probably wondering, who has 20 kids? Well, actually, what about corporations who have to serve up a lot of people who might use an application multiple times? That could be useful because, if, for example, it's a smaller company and they have like a shared pool of data that they can use. Well, now it's all cached and they're not effectively multiplying it by the number of devices every time they're downloading all the resources. So that's that. Let's see if I can. Yeah. Okay. So there's a few things that actually discourage people from using AppCache. We call them gotchas because they get you. And the way it works is pretty much you have to, there's actually more than these ones, but I'm going to mention probably the biggest ones. So one of the main ones is you have to update the manifest file in order to trigger an update to the cache. So that manifest file we saw before, you'd have to make a change to it. What people usually do is at the top, they usually leave a comment and with, with a preceded with a hashtag, and then they would do like v1 or v2, that kind of thing, and that allows them to trigger an update to the app cache even though actually maybe nothing has changed. So it won't actually go to check that each resource has changed. It will actually check that the manifest file has changed so that it's able to update those things. And the other thing is the app cache is actually accessed before the network, which may be a feature or maybe a flaw depending on what kind of application you're writing. So if you make a change, or actually even worse, if you're online and you expect that the cache is updated, it won't. So if it's cached in your app cache will not change just because you're online. And another thing is if you have a manifest file that has a cache header that's set to some far future date, and then you decide, okay, I'm going to deal with that issue by just changing the manifest name from manifest1.appcache to manifest2.appcache. The problem there is that if you have manifest1.appcache in your HTML file and you've cached it with that in the file, then it's going to keep looking for manifest1.appcache and it won't know to look for manifest2, and you pretty much have an app or a site that never updates, which kind of sucks. So in terms of the future, where we see AppCache going, I don't know if you guys have heard, but there's this thing called the service worker, and it's pretty neat. It pretty much allows you to programmatically create an app cache. So it gives all the power to the developer by allowing for network navigation so that you can provide a URL and then you could say, okay, let's respond with something else kind of thing. And it also provides a mechanism to cache resources. If you want more information about this, I encourage you to check out the talk by Alex Russell. He's doing it at 11:40 in Grand A, service workers offline nowish. So actually, service workers also enable some other scenarios, which I've mentioned there. So background syncing, alarms, push notifications, geofencing. These are just a few to name. So it's actually pretty cool, and we see that this might be something that would be pretty cool to have in the internet or in the web. So moving on to File API. So File API is pretty cool because we get to view and manipulate files without a plugin. There were those days where we had Flash and we had to use it to do stuff. Well, now we don't need it anymore. We could do it all with the File API, except a few things, but I'll talk about those in a bit. So we can get file information such as the type, the name, the size, and we can also use it to upload files. If we want to slice that file up into little chunks, so if you have a 1 GB file, we can effectively slice it up and upload it in different payloads, and then have the server reconstruct those chunks. And it's pretty useful that way, because if you have an intermittent connection, you can decide that, okay, we're 50% done, but there's still that 50%. We lost the internet connection. we can continue later. So that's fine. There's also, as part of the file API, there's a file reader, which can get us data as in the data URL, or we can read it as text or as a array buffer, which I'm going to show you in a demo a little bit. And it's pretty cool because it enables us to do some client-side processing. We don't have to actually push it up to the server, so that we're able to do some of the things that we can actually do right in the client now. So the entry points for the file API are pretty much these two. There might be even one more, which is you copy and paste it. I don't know if every browser has implemented that yet, though. So basically, one way to do this is to have the input type file, and then what you would do is you would click browse, and then you would choose the files you want, and you would get a file list back containing the file objects inside of them. You can also drag and drop your files right into the browser, and then you will get the same file list, and you could have those same files inside of them. So a few paths you might want to take once you have those files or those file objects is you might want to convert it to a blob, or you might want to convert it to a blob URL and then go take it to the canvas so that you can actually do some manipulation right on the client, or you can send it up to the server doing an upload, or you can actually store it in IndexedDB so that you have a local copy of that file and any changes you might have made to the file. And it would be nice to have in an email client, for example, if you are writing an email offline and you attach a file, and then all of a sudden, you know, you got connection again, and your file may have changed, but actually the draft that you saved is still going to be the same file that you stored there, because it's going to have no changes. And that's pretty neat, because if you expect that, you know, your email is not going to change when you send it, well, you can be guaranteed that expectation if you use IndexedDB to store that file. So here's one way you might use it. This is pretty much setting an image source to the URL of the data URL of the file. So this is something that a lot of people are doing now. So pretty much what you do is you have the file input, and you look at the change event, and what you get is the e.target.files. I'm just getting the first file, but you can actually scale this up to multiple files if you like. You just have to have a for loop. And then what you do is, if you like, you can check if the type of the file is actually an image. It might be something useful to do. And then what we can do is instantiate a new file reader and actually get the data URL from it. And what we do is we do the onload from the reader, so that once we have that data URL available, we can use it to populate the source attribute of the image to be the result of that file reader. So that's pretty neat in that sense, because now we don't have to exactly upload it to the server and then get it to put it in a temporary location and then give us back that location and then just show a preview to the person when they're doing a file upload. Okay, so this is kind of cool because basically what we have here is a binary file inspector. So what I'm going to show you is something that is going to have client-side capabilities to process a file, get the hex bits from it, and actually try to interpret it, even though the file may not actually be readable by the browser. So I'm going to browse for that PCX file. And as you can see, we're able to use an interpreter that will be able to put it on the canvas. So this uses an array buffer and the data view, and then it puts it up into the canvas, which is pretty neat. So again, this allows for a lot more things that we can do right on the client without actually having to go to the server to do it for us. So for the future, File System API, which has been supported in Google for a little bit of time now, has been deprecated from the W3C, which effectively means the file writer also has been deprecated, which allowed us to do things like saving files right to the disk. So there's a new one that's coming up. I think Mozilla is writing it up right now. It's a File System API with promises, and it will allow for much of the same scenarios that we were getting with the file system API that exists in Chrome right now. The only difference is that it has promises, and there's a few other things with it that make it a little bit easier to use. Pretty much what it gives us the ability to do is have a sandboxed file system that we can work with, we can download from or upload to, that kind of thing. So it's pretty neat in that sense. If you're interested, you can look it up. Right now I think it has a lot of TBDs within it, so there's not a lot of information there yet, but hopefully we'll see more of it to come. So there's also web storage, which we talked about. There's mainly two types. There's local storage, which is something that persists in the browser, and then there's session storage, which actually just lasts as long as the session that you have the browser open. And we're mainly concerned with local storage here, because if we want the application or the site to persist that data between sessions, then we want to have that there. And so that's why we're concerned with local storage here. Pretty much what it gives us the ability to do is quickly set and get items from the web storage, and it's pretty simple. It only allows strings. The other caveat is it's synchronous, so this might be something that you might want to consider if you have a lot of data in there. Of course, there's only a 5 megabyte cap, but what it'll mean is that if you're trying to get an item or set an item, you actually have to wait until you get that thing back before you can continue with your JavaScript. The other thing is that usually people were using cookies before this, and you'd have to send that with every HTTP request, which added size to your payload. If you use local storage, first of all, you get more space, and secondly, you don't have to keep sending that with the HTTP request. So here's an example of how you would use web storage. Pretty much, if you have text that says your last score was, and then you have a number there, you would be able to, first of all, get the local storage object by doing window.localStorage. We're just assigning it to a variable so that it's shorter, so we can use it later on. We can check if it exists already, so by doing lstorage.score and with the exclamation point at the beginning. And if it's not there, then we could just set it to 0. And then what we can do is get the score object, get element by ID score, and set its inner text to the local storage.score so that we're able to get that score displaying to the user. And then if we ever need to do a save in the game, for example, we would have a save method that would actually set that score item in the local storage to whatever the game score is. So here's a game, and it's like, you know, you kind of just match them up and you try to get like 3 in a row or more than that. And notice my points are going up. We already have a results table here. I scored 600 points 3 times, so it's showing up there. I'd have to beat that score in order to have it actually show up on the leaderboard, I guess. So there we go, new high score. Now it says it's 800. What's going to happen is when I refresh this page, bear with me, they told me the internet wasn't going to be that fast. You're probably just going to have to take my word for it. It works. Alright, I'm not going to waste your guys' time. So that's pretty much how we would probably use web storage. Just storing some data and then reporting it back. Basically, again, it's got to be strings, so we could put integers in there and then have them parsed, but again, it's like for simple things. You don't want to do it for something that's more advanced. That's what you would use IndexedDB for. So this is for something that if you want to store something complex and structured and have like a fully capable database with indexing capabilities, you would use IndexedDB. And it allows for larger data than web storage. It also is fundamentally what it is you have things called object stores, and they include things like the value of the object and then a key that would point to that object. and it uses indexes to query for that IndexedDB. One thing to note is that for every different origin, there's a different set of databases. So if as simple as something like the port being changed from port 80 to like port 400 or whatever, you would have a different set of databases. So something to take note of. And it would also mean probably a different quota limit for whatever browser you're using. So we have a transaction model, which allows us to manipulate the data, which is kind of neat because we get things like committing and rollbacks if that's necessary, so that we get some things guaranteed out of that. There's also this idea of asynchronous behavior versus web storage, which is very synchronous. So what you're able to do is listen on events on request objects, and once an addition or a deletion or anything like that is complete, we can do something about that and handle it however we like. And what we can do is we can reduce the number of XHR requests that we would make if we just cached it right on the IndexedDB. So you can imagine that if, for example, we are trying to get some JSON data from the web and we just cached it into IndexedDB, we don't have to keep requesting that data, especially if we know that it's not changed that much. So that would reduce the number of HTTP requests as well. So this is an example of how you would use it. It's obviously a lot more complicated than this, but this is probably the simplest form I can get it in. So basically what you would do is you would open up a database by doing window.indexeddb.open, and then this will, if it's not already there, it will actually create it. So it's going to create this library object, this database. And then what we can do is, again, like I said, it's asynchronous, so we get these request objects back from any of these events, and we could do an onSuccess. We can listen on the onSuccess event and handle that. And what we could do is we could get the result of that, which will give us the database object, which we can operate on. From there, we can instantiate a transaction by referencing the database and then doing .transaction. Provide a range of databases of object stores that we want. So if we had an object store that was called books, for example, in library, we would specify that here. We would also specify if we want to only read it or if we want to read and write. Now it's important that we specify this as we need it, because if we need to do read-write transactions, then that will actually hold up all the other read-onlys, whereas read-onlys can run in parallel, so that you can boot those up all at once, which is kind of nice. And then what you do from there is, from the transaction, you'd be able to get the object store, which is books, and you could do something like get book 0, and that would get you whatever had the key of book 0, and then whatever you want to do there with it, you can. So you're going to get back a JavaScript object of whatever that book contained, which is kind of neat. Oh, there, it loaded. So there's the 800, in case you didn't trust me. Okay, so what this is it's a recipe book, and what it'll allow us to do is search for recipes or for ingredients and for anything else that we want. And what this is going to do is it's going to do it all on the client. It's not going to request anything from the server. So we're going to start here, and we can either search by like breakfast, lunch, or dinner, or dessert, or we can actually search for keywords and type in something like chocolate, for example. Oh, I spelled it wrong. Oh wow, it serves 16 people. So here we open it up, and we can see exactly what that recipe has, ingredients, and the instructions that we have to actually fulfill that recipe, which is nice if you're like at the supermarket and you have your tablet and you don't have an internet connection. You can use this kind of application offline even, and this is totally web technology, so you don't have to rely on anything that's native. So the other thing you can do again is go in by the type, whether it's breakfast, lunch, or dinner. Again, this is just done all through IndexedDB. You can look through it. We can see all the recipes. It's kind of neat, just because, again, you don't have to go to the server. Yeah.
How would you synchronize it to get online content?
Yeah, so what you would do is you would do an XHR request, and you would get that data using like a REST kind of RESTful API kind of thing. You would probably get all the data, like the recipes, the ingredients, all that stuff as an object or as an array of objects, and then you would have like something like a for loop that would populate the database, and you would specify what the keys would be. So for example, if you had recipes with ingredients and you wanted them to be able to search by ingredients, you would want those ingredients to be keys to the recipe so that you'd be able to search for them. Yeah. Yeah, so different browsers will have different size limitations. So it actually depends on which browser. And it's kind of complicated for some browsers. So for example, the simple answer for Chrome is that there's potentially no limit, but there is. It's basically it's a function of like half your disk space, and then each application can have like up to 20% of that half. And for a maximum, if you, for example, had 5 apps that used up their entire allotment, then they would pretty much max out that entire quota. Whereas with IE, it's like 250 megabytes. Initially, it's 10 megabytes. Then there's a soft limit that says enable more storage, so then you can go up to the 250. And then Firefox is also the same. I think it's 50, and then when you enable that, it's unlimited. Yeah. Right back. What do you mean by that? Yeah. So what you would do is you would send those objects back. So if you made any changes, you would use an XHR send or anything like that, get it back to the database, and it would be the server's responsibility to take that information, kind of repopulate the database if that's what you're like. If you're using MySQL, for example. What do you mean by that? Sorry. Oh no, there's no dot synchronize, which is actually an interesting problem. So right now it's something that you would do on your server side code and on your client side code to kind of handle that scenario. And that's an interesting point, because IndexedDB was built with the vision that most, we're going to give you the minimal that we can with some capability, but anything extra that you might want to do is something that you're going to have to do yourself, so that you don't feel like everything is being implemented for you. Yeah.
I suppose this is clear when you clear the cache or install the privacy settings in the browser.
Yeah, so it actually depends browser by browser. So some browsers, it'll specifically call it out as databases, and if you clear it out, like I don't exactly remember what it says on Chrome, but it would have a heading, and then it would tell you web databases would be cleared as part of that. In IE, it's also like it's part of your cache and databases, so that gets cleared as part of that. Yeah, so the way it would work is that it would be shared, but if you had different user accounts, then it would be different. So if everyone had a different profile on that system, then it wouldn't be shared.
So it's user specific?
Yeah. Okay. So just to kind of give you guys an idea of how IndexedDB maps to relational databases, because I know that most of us think in terms of relational databases, especially those people who use SQL and MySQL, that kind of stuff. So databases in IndexedDB are databases, nothing there that's different. For tables, we have things that are called object stores, and they contain JavaScript objects, and they also have the keys that point towards the JavaScript object. To query, we use something called the cursor APIs, and what that will do is it'll provide us a cursor that will let us go through each item and look through it and do whatever we need to do with it. And on that note, if you wanted to do something like a join, you would have to use you would have to actually write code in your application that would enable this scenario. So what you would do is you would have 2 cursors that would potentially go through 2 different object stores, and then you would try to find exactly where each of the keys, the foreign keys, are matching, and then you would do it that way. It's a little complicated, but it's possible to do it. And then for transaction types, so we lock the database when there's a version change. So if you wanted to do a change to the schema, or if you wanted to add an object store, delete a database, add a new database, that kind of stuff, it's gonna give us a version change transaction, which will lock the database, so we can't do any changes there. And when we do read only or read writes on the object stores, it's going to lock the object stores that are in scope for that transaction. So basically for transaction commits, the default for IndexedDB is to commit automatically. You don't really get the option there, which is by design. And how this will work is pretty much if there's no more requests that are being made on a transaction, it will automatically close off and try to commit. If you like, you can abort it before it commits. So if you want to write .abort for the transaction, then you're able to do that. If we want to look up the properties inside of the IndexedDB, we would actually look through the indexes that we create. So what indexes are? They're referenced object stores. So you have your object store, and then you actually have another object store that references to that main object store, and it creates a new schema where the keys are the ones that you specified as the index. So anything that you make changes to on the main object store will actually cascade to that index or that referenced object store. And then if you want to do any filters, you would do something called a key range. And what that will let you do is specify a lower bound and an upper bound on keys. So if you wanted to do something like, if you had like 1 to 10 as keys and you wanted to get 6 to 9, for example, what you would do is you would specify 6 as a lower bound and 9 as an upper bound, and it will give you a subset of that object store, whichever had the keys as 6 and through 9. So when looking to the future, there's a few things that are being talked about, specifically IndexedDB version 2, so the next iteration of IndexedDB. We want to solve a few other problems. Now these are all being discussed on the mailing lists of the W3C Web Applications Working Group. I encourage you guys, if you're at all interested, to look onto that, and if you want to add your recommendations or anything that you're thinking about, this would be a good place to do it. So a few things that have been brought up, not necessarily committed to the W3C yet, but just some things that we're thinking about. Full text searching, or providing primitives that would allow us to provide scenarios where we could provide full text searching. Also integrating the Promises API, which is getting pretty mainstream within with the web right now. So we want to make sure that if that's something that people are interested in, then the IndexedDB should also be using Promises API. Being able to store the file and file list as references inside of an object store in the IndexedDB. Right now, what it will do is it will create a copy, which could effectively create double the amount of space. If, for example, you put a bunch of files like images and you want to store that into IndexedDB, it's going to create copies of those, which may or may not be a good or bad thing, but it really depends. Again, this is just stuff that's being talked about. Another thing that we're considering is regular expression searching through the IndexedDB, which might be useful if you want to do anything that involves regular expressions. Also specifying whether or not the storage should be persistent or temporary, meaning that if it's persistent, then we should expect or be guaranteed that the IndexedDB will stay there until the user actually clears it, or temporary, meaning we don't really care if it gets evicted from the browser, and the browser pretty much could, at its whim, remove it if it decides that it needs space for something else. So also another thing is an exist method to actually see if an object store or index exists. That's something that people have asked for, and it currently isn't there yet. And explicitly allowing the reordering of transactions. So right now, transactions get booted up, and the browser has a scheduler that would pretty much decide when these transactions run based on the actual mode of the transaction, whether it's a read-write or read-only. So of course, that would be pretty neat to be able to decide whether or not you want transactions to run at different times. And then having URLs into the IndexedDB, so something like a data URL, you would have, for example, IndexedDB : the origin of the site, and then the type of persistence it has, the database, and then you go into the object store, the index, the key, and then the key path. And this would allow us to get at an object with just using a URL rather than having to do like sophisticated transactions that would pretty much get us there. So to conclude, I think the main thing we should take away here is that we should think offline first. We should build the application thinking that the network is not available, and that we should enrich the applications to those who do have the network. And again, that could mean something as simple as not having or having just a white page that says, you know, you need internet connectivity, rather than having nothing at all. Of course, that would be the least optimal scenario, but something is better than nothing. And you would use these APIs such as IndexedDB AppCache, web storage, file API to allow you to do much of the processing and much of the data collection and data mining right on the client, rather than having to reach over to the server and rely on the server to do all of this. And this could actually provide us with some benefits as people who manage servers or databases, where we don't have to have as many requests being pulled to the server. They can just do this stuff right on their browser, right within their application. And of course, your applications will work faster, perhaps load faster, and they'll be able to work offline. All right, thank you guys, I appreciate it.